Hey, what's up? Jason here. If you've been looking at getting into the game industry, maybe thinking about getting a game dev job, or maybe you're working in a game job and considering getting a new one, or even working as a game developer and considering interviewing or hiring developers, this might be a perfect video for you. Today, I'm going to cover some of the top interview questions for game developers and specifically Unity developers. I'm going to hit some questions that I've seen asked in a bunch of different companies, including some non-game companies, and I want to talk a little bit about what the differences are there and some of the questions that you'll see in some of the companies that are doing non-game development in Unity, as opposed to some very game-specific questions. So if you're excited about that, or you're interested in just learning about how to get a game dev job or how to get into the industry, or you just kind of want to practice up on your game dev questions or see if you know the answers to these, hang on with me and it should be a lot of fun. But before we do, I wanted to mention that I just hit 100,000 subscribers and I'm really excited about it. So I'm working on a couple of different things that I think are pretty exciting and fun. The first is going to be a new video that teaches everybody how to make a game in Unity 2020. And the second, I'm going to do an office tour showing a lot of the tech stuff. I really like a lot of cool tech things that you guys have never seen, and then all of the stuff that I use to record. So if you're interested in either of those, please just drop a comment below. Let me know which one you think is more exciting. I'm going to do them both, but it might help me decide the order and finish that up. And if you have any suggestions or recommendations for other videos and things that you'd like to see in the future, drop a comment below too and let me know. All right, I think it's time to get started. Hit the like button, hit the subscribe button, and we'll get going. Now, this first question I've seen asked at a bunch of places. I think you'll probably see this just about anywhere you go, and that's, what's the difference between update and fixed update? Now, I think this question gets asked a lot, not just because we really need to know it to understand how to use input and how to use the physics system, but also just because it's kind of a fundamental, simple one to ask, where there's an obvious answer and an obvious yes or no, true or false, correct answer. So let's dive into what the answers are to this. What are the differences between update and fixed update? Why would you use one and not the other? And why do they both exist? Well, for anybody who's not super familiar with the way that this all works, a game engine essentially runs some code in a loop, and then it's, in Unity's context, looping through all of our code and all of our objects and running the update method on them every frame of our game. So if we're running at 100 frames per second, if our game is able to run that fast because our computer or our system is able to run that fast, it's going to run the code in our update script there 100 times a second. And it does that with some internal looping that it has going on, where it says, hey, every frame at the end of the frame, or during the frame, not really at the end, but in the middle of the frame, use all of the scripts that we have enabled and run the update on them. Now, that's great for our game logic. It's great for reading input and quite a few other things. In fact, it's great for most of the code that we write. Well, not most, but a lot of the code that we write. Anything that we want to happen and change or update on every single frame. It also, though, runs another loop. So there's this update loop running that's just going as fast as the game can go. And then there's another loop called this fixed update loop. And in that fixed update loop, Unity's handling a couple of things. It's handling the physics for our system and, well, our code for the fixed update. And those are really the only two things that you need to care about. But essentially the movement and physics handling, so an object falling down or an object colliding and hitting something else, those are handled by this totally separate loop. That loop does not run as fast as the game can run. It runs at a set rate. The default value for that is actually 50 frames a second. Now, that doesn't mean that it always runs at 50 frames a second. So because we have a fixed update that's set to run at 50 frames a second, doesn't mean that we're always going to get that. If our game drops below 50 frames a second, our fixed update is going to drop below that as well. So if our game's fixed update rate is set to 50 and our game's frame rate is set to running at 30 because our system just can't handle it or we're overloading it, our fixed update is actually going to slow down to 30. What's going to happen though is it'll never go above 50 because these are physics calculations that we don't need to run any faster than that. And they're usually heavier calculations that there's no benefit in calculating them at any higher speed. Now, sometimes we turn that value up. So let's go into Unity and see where we can change the rate that our fixed update runs at, or our fixed time step. To do that, we'll go to Edit, and then go to Project Settings, and then find the Time tab down here. Here you'll see that our fixed time step defaults at that 0.02. That's the 50 frames a second. And if you're not sure how that works, you can always just open up a calculator and divide 1 by 0.02 to see what our frame rate is, 50 frames per second. All right, now I'm going to close this out and I want to take a look at some code and then see what it does in our console window. So I'm going to open up my questions script here, and here I've got very simple code. We have an update that logs out the word update in debug.log with our time and a time.delta time to show how much time has passed in our update. And then I do the same for fixed update, but I'm logging it as a warning so we can see it easier and putting in the word fixed update. But we're also using the word time.delta time. And I wanted to point this out, that there used to be a restriction. We used to need to use time.fixed delta time when we were in fixed update. And otherwise we would end up multiplying by a wrong amount of time that had passed. This has changed. They made a change. I don't remember the exact Unity version, but the way that it works now is if you call time.delta time or you read time.delta time from within a fixed update, you actually get the fixed delta time. And now you're going to see that in action. So I'm going to save my script and go into Unity and just hit play. I've got this question script just attached to a game object with nothing else in the scene. I'm going to go hit play and we're going to take a look at my log as it spams out. So here you'll see I've got a bunch of updates and well, occasionally a warning going by. I'm going to pause and just grab my console window, see if I can resize this thing and make it nice and big. There we go. So let's just take a look at one of these updates and fixed updates. So here's that fixed update running at 7.16 seconds in. So the time.time is actually the amount of time since our game has passed in seconds. So at 7.16 seconds in, we ran a fixed update and it took 0.2 seconds. Or it didn't really take 0.2 seconds, but the time since the last one was 0.2 seconds because that's the time that we have our thing capped at. That's our maximum frame rate, or our minimum time. We could never get a time lower than that because that's what our fixed time step is, that 0.02. Then we saw an update. The update was much, much faster. It's got another 0 here. It's not 0.017, it's 0.0017. So it's actually quite a bit smaller. And then we got another one that was about the same, another one about the same, another one, another one, another one. You can see, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 update calls between every fixed update call. So you might start to notice some of the differences here and maybe think about some of the reasons that you would want to use fixed update versus update. Now remember, if we're doing our movement and we're doing our physics stuff in fixed update, or our physics control and physics system is doing that, we probably want to do movement related things in fixed update, like adding forces to things. If we add a force in an update here, add a force here, add a force here, add a force here, and add a force here, they're all going to just fire off, or just the last one to fire off. I forget which one now. You're going to get strange behavior and you're going to have problems. You don't want to be doing that. You want to do your add forces and those types of calls in your fixed update. And you want to do things like input reading in update. Now let's talk about why you would want to read inputs in update. Imagine you're pressing a button, right? So imagine I'm playing the game and at 7.717 seconds, I press the A key. And we have some code in our update that says, hey, if get button down or get key down key code A, if that's true, then do something. Great, that'll work just fine, right? But let's say we moved that code over to our fixed update. Suddenly, our get key down is not going to be true because get key down will be true for this one frame right here. It'll be false for this next frame. In fact, we'll have get key up maybe in this frame, or we might have get key up by this frame and way before we've ever gotten to our fixed update. So we can't read these event-based input type things in a fixed update. And we can read things like a horizontal axis or a current button state because that's really just going to give us the state of it at the last frame. So it's not really going to matter. It's not going to be an issue. But for button presses, clicks, and those types of things, we need to make sure that we're reading those in update and not in fixed update. Those are really the biggest differences. This next question is pretty important to understand and doesn't take a whole lot, but seems really complicated or confusing at first, especially from an outsider point of view. And that's just, what do you know about coroutines and threading? Or things like, you might see the question worded as, are coroutines threaded? Or how do coroutines work? Or how do you do threading or delayed things in Unity? And really, it's kind of a big, complicated answer, but I think I can boil it down in a minute or two. And the answer is really just that Coroutines are a way in Unity to run some code over a period of time or at a set period of time, or maybe after a period of time. It's usually used to do things as a delay or to do things over time. So I've got some amount of health that I want to take like every second. I might write a little coroutine that says take 1 health per second or take X health per amount of time or whatever it is with some variables in it. Now a coroutine is not threaded. If you're familiar with threading, it's essentially running code on one processor or one core of a processor and then running more code on another core of a processor. Processors nowadays have 8, 32, 64, 128 cores in them, and you can thread things out extensively. Coroutines do not do that. They use a built-in state machine that it kind of puts together under the hood to make it easy to do some simple asynchronous things and waiting type things, but it's not actually utilizing another thread. It's not adding any performance. It's actually costing a tiny bit of performance. It doesn't mean that they're a bad thing to use or that you don't want to use them. You just don't want to have them be your default for everything, and you don't want to use tons and tons of coroutines if you don't necessarily need them. They can be a great solution for a lot of problems. They're not always the best option though. Now there are a couple important things to know about coroutines in addition to that. One is that when you start a coroutine, well, you can start it by name by giving it quotes around in a string with the name of the method that you want it to call, or you can give it a reference to the method. It's almost always better to just give it a reference to the method. So you put the method name in instead of the quoted name in there. And that's just so that if you rename the method, it gets renamed with it. One other thing that I think is extremely important that people don't realize is that when you call StartCoroutine, you get a reference back to that coroutine where you can actually check some info on it and stop that specific coroutine. So if you want to have a reference to a coroutine that you can kill later or do something with later, you can actually get that and you get it automatically. Most people just don't see that because that's not how StartCoroutine is written, but it does have a return value of an operation that you can actually access, and you can use that to stop things. You can also stop by name, or you can stop all coroutines, but I'd say generally you want to manage those references to them. You don't want to do wild things against all coroutines because you end up, well, with plugins and other things breaking stuff. But yeah, that's pretty much it on coroutines. The key thing there is just remembering that they're not threaded. They're not like a performance benefit. They're just a way to write easier asynchronous code, kind of like an async and await in generic C# stuff. This next question can come in a bunch of different ways, and it's essentially to solve a simple coding problem. Now, one of the most common ways that I've seen this presented, and the way that I see it presented all the time outside of the game industry and sometimes inside the game industry, is with the simple problem of FizzBuzz. It's a simple math game or division game. You can read the description on Wikipedia. It says it's a group word game to teach kids about division, where they take turns counting incrementally and replace any number divisible by 3 with the word fizz and any number divisible by 5 with the word buzz. So you essentially go 1, 2, fizz, 4, buzz, 5, fizz, 7, 8, fizz, and then so on. And it's one of those things where you got to kind of keep going up, and eventually you get to 15 and you do FizzBuzz because it's divisible by both. That's where the name comes from. So the problem in this situation is to write code that will do that. That'll go from 1 to whatever number and write out the number or fizz or buzz depending on whether or not it's divisible by that amount. Now there are two key parts to this. One is understanding basic loops and understanding that you can just loop through a number. And the other is knowing about the mod method or the mod operator in C#. If you don't know about that, this becomes much, much harder. So I'm going to show you exactly how to solve this problem. You can find the solutions to it everywhere. So it's not like I'm spilling some special secret, but it's important that you should be able to read this, understand it, and clearly be able to replicate something like this. If you have a hard time with that, I'd recommend that you just keep practicing writing code and start doing a bunch of code problems until you can get those down and just get it out of the way, because it should be pretty simple for you to write something like FizzBuzz when you go into a game developer interview or pretty much any programmer interview. All right, let's get to the code. So here we go. I've got my questions class changed up, and now I've got a field for a max value. It's an integer set to 100, and then in on enable we call FizzBuzz. And here it's just using an expression body method to shortcut this down and get it in one line instead of 4. So FizzBuzz is a method right here that starts with a simple for loop. We loop from 1 to our maximum amount, which is that 100, and we increment by 1 every time. If our value I mod 3, so that's the %3, is equal to 0, and what this is going to do is just say if this is divisible by 0. And what this really means is, hey, when we divide this by 3, if the remainder is 0, because this just divides it and gives us the remainder. So if dividing it by 3, and remember old school, like your math without decimal points, we get a remainder. If that remainder is 0, then it's divisible by 3. If it's also got a remainder of 0 when we divide by 5, then it's divisible by 5 as well. So we log out the word FizzBuzz. Otherwise, if it's divisible by only 3, so it wasn't divisible by both of those, we already checked to see if it was by both of them, then we just log out the word fizz. And then here, if it's only divisible by 5, we log out the word buzz. And if none of those conditions are met, we log out just the actual number. Now you might be wondering, can we optimize this? Could we change it up? Could we do something else and check, hey, like if it maybe do the if statements only once? And sure, we could probably combine some strings around and do a bunch of other much heavier stuff than some simple division. But I would recommend just keeping it relatively simple. I think that a lot of the optimizations that we could do here to make this faster would really not make any real difference. And that's not really the problem here. The problem is, can you write the code? Can you write it in a way that's easy to understand? Do you understand what's going on with it? Or are you just getting completely confused and you don't actually know how to write code from scratch? So understand some of these problems and maybe go through a couple code practice problems before you go into an interview. It'll make you feel a lot more confident, and I think it'll really help you kind of get your mind going and be ready to solve problems when these come up, because you're always going to get at least one kind of problem like this where they want you to solve some kind of code thing. And don't get me wrong there, that's not a bad thing. You should definitely be getting interviewed and questioned about a lot of code things. And if you're interviewing people, you should definitely be asking these kinds of questions. Don't just assume that because they know all of the high-level ideas and they've got these high-level concepts down, that they also know how to write the code. Make sure that you test them on that and that you verify that they can actually write functional code and read code and understand it. It's easy to get through some of these things sometimes without that. So you need to make sure that you're checking for that. You also just need to make sure that you're prepared for it and that you're ready to write some code, or at least read through and understand it. But ideally ready to write some simple code to solve some simple problems. The next question you'll probably see that has a somewhat confusing answer or somewhat complicated answer, or I guess less than straightforward answer, is how do you save data in Unity? There are really a bunch of different possible options. You could write stuff off to a web service, have some external hosting provider that's maybe handling all of the data and you're just posting it out to there. Or you could write it out to a local file or something else. But usually the default answer, and the thing that we want to go with, or that they want to make sure that you understand about, is the PlayerPrefs system that's built in. Because it works across a bunch of different devices by default, it's relatively simple and straightforward and usually handles most of the problems that we need to solve with it. Now, there are a couple different ways that you can use the PlayerPrefs, and I want to show you, well, two of them, the two most important ones. And the first is just by setting and getting data. So here I've changed my questions to just have an enable count, where we have an integer that counts the number of times I enable it. And I actually forgot to delete that other line, so I'm going to clear it out. So in onEnable, I just read my enable count from PlayerPrefs, calling PlayerPrefs.getInt and give it a name. PlayerPrefs are stored as a key value pair. You can either store integers, I think floating point numbers, booleans, and strings, and I forget the other things. The main ones that I use, though, are integers and strings, and you'll see why in just a moment. First, though, is integers. So here we're getting an integer, and we're going to get back a default value of 0 at first because there's no value set. I can also add a comma here and give it a different default. So if I want the default value to be 1, I can set that as 1. Otherwise, it's going to go to the default for an integer, which is 0. Then I increment it, and then I call PlayerPrefs.setInt. So what'll happen here is if I run this once, it's going to read a 0, increment it, and then set it to 1 in this PlayerPrefs. Then I'll run it again, it's going to read a 1 and set it to 2 and then go up. Then I'll read it again, it'll go up and up and up. And it's going to persist across runs of the game. Now there is a way to clear this. If I add in a line called PlayerPrefs.clear, or what is it? delete all, I can clear all of the keys, or I can delete a specific key by name. Usually you don't want to do that though unless it's like a clear or remove settings, and even then you're probably setting it to a default. It'd be maybe a clearing progress or something, but that's not a very common thing. Usually we're going to be setting it and getting it, and maybe clearing it when we're debugging it. So let's talk about strings. Why do I use strings and ints primarily? Well, because strings are great for saving off names like the player's custom name or something that they've put in. They're also great for saving off actual class data. And I want to scroll down here and show you another way to save things. So here we're doing some JSON serialization or JavaScript object notation serialization. It's really common in web development and a lot of other programming, and it's something that's available to us in Unity as well. I'm going to zoom out just a little bit so you can see everything that we've got here. So we've got a public class called player data that has a player enabled count and a level field on it. And then we have a method here called write player data with JSON and a reference or an instance of player data right up here on line 24. So in our write player data, we're creating a var named JSON data, which is really a string. Let's just type it out and make sure that it's really obvious, because JSON data is just a string set of data. JavaScript object notation is a string. And we call JSON utility.toJSON, and we pass in our player data. What that's going to do is convert all of the data about the instance of our player data. So whatever our enable count is and whatever our level is, those are going to get stored off into a bit of JSON data, and then we'll be able to read that later. But first we'll store it off into a string, and then we'll write the string into this player data, and we'll end up with this big blob of text in there. Then in read player data, we can do the exact opposite. We'll get a string just like we get an int above, and then we'll read from JSON. So we say JSON utility from JSON and give it the player data type. And here we actually need to specify the type of the object that we are deserializing out of JSON format. And then we pass in the object, and it's going to give us back an object of this type. It's going to take this data and convert it. Now, if that data is not convertible, if it's invalid data or something else, we're going to get an error instead. So we need to be careful that we're actually giving it valid data. But this will work, and it will let us save off a bunch of information without having to write out a whole bunch of different fields. And it also makes it easy to send data across the network. It's also important to note that we don't necessarily have to serialize as JSON. There are other ways to serialize this into a string that's maybe XML or a binary format or some other way that maybe the player can't read. If you want to save off some custom saved data that you don't want your players reading and getting into, you can encode this or encrypt the data. You could JSON serialize it and then encrypt it, or a bunch of other options. But you don't just have to write it out in JSON text. Now, if you make it through the update versus fixed update movement questions, they might start asking you some more stuff about moving objects around, or maybe how do you move characters, or how would you move this specific type of thing? And the answers to that can vary. You really want to get a little bit of context. If it's an object that they're talking about that maybe is a character that moves along a ground or a plane or something, or some sort of an environment that's kind of baked in, you probably want to recommend something like the Unity Nav Mesh system, or maybe the new Nav Mesh system that they've been putting together. It's got a whole lot of support for a bunch of different features that didn't used to exist. You might also want to recommend building your own, but maybe leave that as a last resort, because the built-in one is pretty fast, really works, and probably will get the job done for you. Now, if they say, hey, that's cool and all, but what if our game won't work with Nav Mesh because we're in outer space and we need to have it so that this ship moves from point A to point B, maybe it moves from space station to space station, and we need it to go at exactly the speed. How would you do that? Well, then you'd need to tell them, hey, well, we can maybe aim this thing and then set the velocity or directly control the velocity of the object. Or they might say, hey, we want to move this object from space station A to space station B, and it always has to take 1 minute. It should always take exactly 1 minute, no matter how far the distance is. It'd be kind of weird, but it could be one of their restrictions or constraints that they have, that something is time based on how fast or how far it moves. So in that case, you would want to recommend something like maybe using some interpolation, like using a vector3.lerp or vector2.lerp if you're building it in 2D. So you need to be able to, think about the different options and then just talk intelligently about them to them, figure out exactly what it is they mean and that you're recommending solving the right problem. Don't just go off, hey, we want to build, well, we need to build out a whole new A-star pathing system. We need to build it. Don't go overboard and crazy with the thing. Start with recommending the simple stuff, the things that are built in, and finding more information. It's good to recommend, or I guess good to just ask questions and be the kind of person who's going to be inquisitive and make sure that you're building the right thing, because it shows that when you get a real project, you're not just going to hear the first little bit of it, take off and start running down the wrong path and building the wrong thing without asking questions. Asking questions is extremely important as a software developer and a game programmer, so doing it in the interview is really important as well. And it's a good way to keep the communication going. Now that leads us into what I think is sometimes the most daunting question, especially for new developers, and that's to design some system. Now, it may be some score system or a gameplay system or a combat system or maybe just some networking system or something very specific to the game that they're working on. But often they'll ask you to come up with an architectural design for it. Now, that doesn't mean creating every single class and writing out every single method. They don't want you to implement the thing. They want you to give them a high-level understanding of how you would put things together. Now, this is a great opportunity to ask questions. It's really important that you do ask questions about what the system is there for, what it's designed to do, and what the context is. It's also important that you ask good questions that are important questions. Don't ask totally irrelevant things like what color should it be or something else just to fill time because you're confused and trying to distract from the fact that you're not sure. Ask questions about the way that it works, and maybe if you're not sure where to go from there, like, well, let's give an example. Let's say that they say, hey, design a score system for me. Give me a new score system. And that's it. They say, hey, how would you design a score system? Well, first question would be, what kind of game is this? Like, is this a game where we have one score? Is there one player that we're keeping track of a single score? And are we keeping track of high scores, or are we just keeping track of a score across the one game? Are we keeping track of multiple player scores? How do you gain points in this game? Is it from killing players or killing NPCs or collecting a thing? Are there different scores that we can have in this game? And you don't need to go just diving and throwing a ton of questions at them. Ask a single question, get an answer, and get them to elaborate. A lot of the time you can just ask the one question and they'll go into a lot more detail and they'll elaborate on it. And you might need to ask 2 or 3 questions to kind of follow up, but don't just give them nothing and just ask questions either. Don't just sit there and go, hey, question, 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 and 10 minutes in, you're still asking questions and haven't gotten to your actual design idea. Now, what should you design? So say I'm designing a score system. Let me just give you an example of what that would look like. So they go, hey, Jason, design a score system for me. So, okay, what's that score system look like? Well, what kind of game is it? And they go, well, we're building a fighting game, right? It's maybe we're building Teenage Mutant Ninja Turtles arcade game. You got 4 turtles, 4 players, and they run around. Every time you punch a bad guy, you get points. Every time you kill a bad guy, you get some points. And that's pretty much it. And I go, okay, well, that gives me enough context. And if maybe they didn't get into that much, they just said it's a fighting game, I might say, hey, how many players was it? What do we do with the scores? When do we show the scores? Do we show the scores at the end of the game, or do we show the score as the player's playing along? In this condition, I'm thinking, hey, it's showing it up the top of the game the whole time. So how do I design that? Well, I think, well, okay, we got 4 players. I've got a couple different options. I could probably just assign some sort of a score object to each player independently, thinking that the player is or just a one-time object that's running around throughout the game. That player keeps the score through the end of it, and then maybe they save it, and the way that they save it off is something different. I don't care so much about how they save it, just thinking in an arcade term, because it's not really associated with the player. It's just going off to a high score system, which would be somewhat different from this, because this isn't like a long-term player that's persisting, right? We're not keeping it around like an MMO player or a Diablo player. So it's just a score that keeps with a single player. It would stick to that player, and whenever the player did something that was score worthy, I think I would assign them some sort of, well, how would we do it? Let's think about it. Let's think it through. So go, okay, we've got a player here. On an enemy getting hit, I would fire off an event to the thing that's hitting it saying, hey, you hit me. And then if that thing means that you get score, then you get score. In fact, maybe what I would do is set it up so that only specific NPCs and only specific things give points to when they get hit. Because I'm imagining like maybe I have different NPCs that give different point values when I hit them. So I'll assign something on the NPC, perhaps a separate script that's like a point value script to it. And then when I do a hit on that NPC, if it has a point value assigned to it, and maybe I'll put this directly on the NPC, maybe it'd be a separate script, but when I do a hit to it, if it has a point value assigned to it, it will maybe call back or be the return value in that hit method that I call, or I might fire off an event for it. There's so many different options here. So you can just keep going on and on and on. And even I'm starting to just kind of lose myself in the different options for this. I could also just set up a completely separate score manager system that has players associated with it. And then whenever an NPC takes damage, it can say, hey, I took damage from this thing. Anything that's listening, listen and go assign points, right? And then the score system could say, hey, I'm listening to all NPCs. Whenever they take damage, they fire off an event that says, hey, I took damage. And then if they'll pass in the thing that they took damage from in that event, and then maybe that score system could associate a score with the player. And it really just depend on my mood, how I felt about it, and how the rest of the game was architected. If the rest of the game is architected with characters that have just a lot of scripts on them and most of the logic is on those different scripts on the actual player or character object, then I'm going to stick with that way and keep it the way that the rest of the game is built so that it's not confusing and that people don't have to learn a bunch of different techniques when they're in this one project. Everything works kind of the same. And if it's the other way where we have a bunch of different systems that are out there listening for events and responding to them, then that's what I'm going to do. I'm going to go with the pattern that we're using in the project. And I think that it's worth mentioning that too. Like, hey, well, this is one possible option, but I'd also look at how we do things in the rest of the project and make sure that we match it up with that and kind of stay along with the patterns and practices that we're already using. Also, don't overcomplicate these solutions. It's very important when you start to design these systems, like you could come up with the most complicated, most crazy thing ever, right? Like you can go up to, hey, we need to switch over to a completely reactive system where we're firing all these different events or change something out, or we need to save all this data remotely. Like you may not need any of that. A lot of the time they want to make sure that you're going to go with the solution that gets the job done quickly and isn't overcomplicated, doesn't make it a mess to deal with later. So don't just go to the most complex solution, go to the thing that works, gets it done, and then offer that, hey, there are other options if we hit constraints. All right, let's wrap this up now. And I want to just briefly talk about the final little tip here. When you're going in for an interview at a game industry job or any programming job, really, it's really important to make sure that you understand what you're getting into and you understand what the game company is or what the projects are that they're working on and what kind of stuff that you're going to do. So if you want to prepare for questions that they're going to ask, start looking up the company. Google what their questions are. You might be able to find them online, but also Google what their projects are and make sure that you understand the types of things that they work on. If they're working with the universal render pipeline in their game, make sure that that's a thing that you understand. If they're working with dots, then make sure that you are at least familiar with dots. Whatever the thing is that they're working with and that they're using a lot of, try to get a little bit familiar with that and be prepared for it. And also, it's not just these systems either. It's also just the game types. Make sure that you're familiar with the actual project, the product that they're working on, that you've played the game and you've played it a decent amount and understand it and can speak intelligently about it, or that you've seen and used their product if it's a publicly facing product that you can get into. It really helps, and it's really important to know whether or not it's going to be a good fit for you too. Because if you get in there and you hate their game like from the start, just playing it, you're probably not going to like working on it, and you should probably start looking around somewhere else. All right, I hope that these questions are helpful. I know it was a lot, and I know I talked for a long time. If you have any questions that you want to ask, just drop them down below. And if you have recommendations for interview questions or fixes for any of my solutions, please drop them down below as well. Also, don't forget to hit the like and subscribe and all that stuff. And yeah, thanks again, everybody. I'm running out of breath. Bye.